functions and their applications, which is being organized by MTTF India, in Punjabi University, Patiala, India, Purnima University, Jaipur, India, Sardar Patel University, Gujarat, India, École Normale Supérieure de Mécanique Moulay Ismail University, Morocco, and Baba Farid College, India. Dr. Mehar Chand will be the keynote speaker for next session. Let me give his kind introduction to all of you. Dr. Mehar Chand is working as an assistant professor in Department of Mathematics, Baba Farid College, Bathinda, India. He is working in the Department of Mathematics where he teaches courses and work on supporting math students and the broader math community in various ways. His research interest is involving in fractional calculus and its applications, mathematical modeling, numerical methods, computational mathematics, spatial functions, hypergeometric functions, and mathematical physics. He has published more than 70 research papers in national and international journals, which include SEI journals, SEIE journals, and Scopus Index journals. He has also published 5 book chapters, which are being published by Spring. He has delivered more than 29 invited talks as keynote speaker in national and international workshops and conferences. He has also delivered 9 expert talks in national and international faculty development programs, workshops, and seminars. He has organized 24 national workshops, 2 internships, which are sponsored by DSP, and 19 webinars or seminars. He is a member of 5 academic bodies, and he is a founder and president of MathTech Thinking Foundation, which is a Ministry of Corporate Affairs government approved NGO. So, Mayor sir, over to you. Kindly start the talk. Thank you.
Thank you, ma'am. Thank you for the introduction. This is the putting part, and throughout the session, I try to discuss all the basic functions which I target in the session, and all the things will be on hand. So I will not use here any PPT. I prepared a script file, and some functions which we target in this session will be very helpful when we generalize or extend a basic function or further generation of the extended functions. And only the extension, if we have their numerical results and numerical interpretation, graphical interpretation, then these things are very helpful, very useful when one want to apply in other branches of science or engineering. Special functions and occurs in various type of problems in physical sciences and engineering, and the extension functions when we apply to find out the solutions of fractional calculus, fractional differential equations, which appeared in the form of a new extended function. So in that case, many times we need their numerical and graphical interpretation. But in that case, new functions are not available in the MATLAB or in other programming. There are some elementary functions which are available in MATLAB or other softwares like Maple, or even in the Python also elementary functions are available. We can use by using SymPy library. But in the case of MATLAB, when we need numerical and graphical results, how we can use? So first, I would like to share my MATLAB window with you. My window is visible too. MATLAB window is shared with you. Please let me know.
Mehar Chand, please share.
Yes.
Please share the screen. Share the screen because I suddenly out of this link. Okay. Rejoin it again.
Just 1 minute. Not visible?
No, still not.
Okay.
So this is a problem of net. It is not actually in our hand.
I think there is a network issue. Just
Yes,
1
yes.
minute.
Yes,
Please
definitely.
wait. Please wait. Just 1 minute.
Okay. I put it in the in chat. Now your screen visible, Professor Mehar. Professor Mehar, now your screen visible. Yes, the Mittag-Leffler function. Now screen visible.
Yes. Now I think you can see this PDF file.
Yes.
And one is MATLAB window. Okay.
Yes.
Yeah. Okay. Thank you, sir. Thank you for supporting me.
Okay, visible. Fine.
Thank you, sir. So now you can see this is the MATLAB window, and there are several partitions. On the left hand side, you can see this is the current folder, and this is a major partition in the MATLAB window. You can see this is the command window. All the basic command we can easily execute in this part. And on the right hand side, there is command history. When we execute any command in the command window, these will saved automatically in the command history, and you can use again. And this is the workspace. When we use any command in the command history, command window, the corresponding value will be appeared in the workspace. So now, see, like I assigned a value a is equal to 5, and this semicolon is used to control the statement. If I am not using the semicolon and I am entering, this will return the value. If I am using the same like in this a is equal to 4, and I'm using here semicolon. This will suppress the statement, and when I will enter, the corresponding value of a has been assigned. You can see in the workspace at this place. Okay, and you can see in the command history also, and also the same value is appeared in the workspace. This is the value of a. Okay, and if you want to change this value, you can assign again a is equal to 6. The value automatically will be changed in the workspace. So the latest value will be, you can see in the workspace. Okay, command history, all the commands which we enter will be saved in the command history. And the semicolon is used to control the statement. Okay, so when we have multiple statements, then we need to control the sequence of command. This will be very helpful. So now CLC is used to clear the command window, as yesterday explained many things by Dr. Kumar. So these are very simple. Now there is a help function. See, help ELFUN. So when you will enter this statement or command in the command window, and when you will enter, so this will return all the basic elementary functions which appear in the command window. So the many things are connected with this system. MATLAB is there, streaming is there. So the system will a little bit slow. Don't worry, but all the things will go very smoothly. And if there is any connectivity problem or disconnect, please wait for 1 minute. All the things will be there. Okay. So you can see all the elementary functions are there. This is the list of all the inbuilt functions in the MATLAB. Okay, you can see sign, then sign D. So from this list, the most important thing is to understand the syntax of MATLAB. And once you are able to understand the syntax, how we can use, then you will be able to create any mathematical function and you can use. So from this these functions, you can easily find the syntax is sign and sign D. Okay, so when you click on the first function sign, this will open. The system is now heavy, so it is taking some time. So I have clicked on the sign and it is opening, and now you can see these are the syntax. Okay, when the system don't have many functions, so it will open very frequently and depends upon the preferences of your system. So now you can see this is the syntax and you can easily use in the command window. See here, and also see the argument. Argument is here radians. Okay, so when you will assign any value at this function, I am giving at this place 90 and it will return 0.8940, and this value return on in that form of because argument is here radian, and if you will use this sign function like D, this will consider the argument is degree. See, okay, so you first need to understand all the elementary basic functions which are inbuilt, and corresponding all the examples are available, and is detailed about this argument you can check. Just you need to click on any function which are inbuilt in the MATLAB. Okay, so these functions we can use, and these functions appear in the form of various type of special functions and their extensions, and many times these are required, and each corresponding function has their syntax. You can easily find these. Now, like a gamma function, gamma is also inbuilt function and you can use like in this way. Okay, this is the gamma, and when you will enter, it will return the corresponding value. And similarly, beta function is also inbuilt function, and you can assign the value, and when you will enter, it will return the corresponding value. Data and 2, 3. Sorry. Okay, some problem. Now the problem is that when we have external functions. So see at this place we have I am discussing some functions in this paper. So here you can see this is the table and the generation of Mittag-Leffler function. So now if we want to interpret or we need numerical results of this function, first we need to understand which functions are involving in this function. Okay, so see at this place to interpret or for the numerical result for this function, we need this case symbol, and then we need this a gamma function. Okay, because these two both functions are appeared in K Mittag-Leffler function. So first we need to create this function K Pochhammer. So see in the MATLAB. Okay, here we need to apply loop. Loop function will be applied at this place. Now see in the MATLAB, I have created a very simple program, and all the files you can make a current directory. You can see this is the my folder. All the files are available on the desktop, and this is the this is the my current folder. All the current files are available in this. Okay, these are the PDF file, and then at this place these are the current files which I have created. This is script file. Okay, so first we need to make this folder which is available on the MATLAB as current directory. Just click at this place, and then you need to select desktop, and then after when you will select desktop, you can see this is the programming folder, and make it current directory. Just you need to select it, and when you will select, the folder will become current directory. Okay, now the files are available in this folder. Just you need to double click. So now here we will discuss about the Pochhammer symbol. Then you double click, then a Pochhammer symbol, then we have a gamma function, and after that we will discuss about a Mittag-Leffler function, and at the end we will plot this function. Okay, so all these things we will discuss one by one. So first we need to understand about Pochhammer symbol, and this is nothing like if we have x n, we can write a like x n plus n upon gamma x. Okay, so gamma function is the unit function, and simply we can write this Pochhammer symbol is a function, and then we can use it. So as discussed yesterday, this is we write this function, and then we can give any symbol notation. I assigned here notation P, and you can give the name of the function. Here you can see Pochhammer symbol, and this Pochhammer symbol contains two parameters. One is A and other is N. Okay, so we give here two arguments, and then P is equal to gamma A plus N upon gamma A. Okay, this is inbuilt function. This is inbuilt function, and we are using the same pattern. See, this function, this will be in MATLAB. The script for this will be gamma A plus n divided by gamma A. So this is the MATLAB script. Okay, syntax. So this syntax will be used and C at space. Okay. So this is the Pochhammer symbol function, and all the details are available about this function, and this will be very helpful for you when you will use. So now how we can use? Copy from this place. This is the function, and we will use directly. See, we will assign any value at its place. If I have A is equal to, suppose that 4, and the value of n is 5. So when you will enter, it is returning the corresponding value. Okay. So we have created here very simple, which is Pochhammer symbol function, and very familiar in special function. Okay. Now we are discussing about K Pochhammer symbol, which is the part of you can see. This is the K Pochhammer symbol, and here the thing is that first factor is x, then we have x plus k, x plus 2k, and x plus n minus 1k. Here we have to apply loop. Okay, and this is very quite simple. So when you are going to apply loop, for loop, in that case, first you need to assign first value. Okay, see in the matrix. So first you need to understand. First, see how many argument we required for this Pochhammer symbol. You can see x, n, and k. These three arguments are required. Okay. So in the first we need to define the function. This is just a symbol. Nothing. You can assign any value at its place. And this is the k poch, or you can extend this like a k Pochhammer symbol. But we will assign very simple symbol. Okay. Then we have the arguments x, comma n, comma k, because this k Pochhammer symbol involve three arguments. So in the first, because when you are going to apply for loop, we need first value, and the first value we are choosing here 1, because either because this summation will extend from n equal to 1. Okay. So we are assigning here 1, and you will multiply this side with 1, no change. Okay, so depends upon the function. Now this is the constant value. Then we apply here for loop. Okay, and this loop will vary from 1 to n. This loop will vary from 1 to n. So how this loop will work? See, first we need this value. First we need x. Then we need x plus k. Then we need x plus 2k. Okay, and so on. And last term is we have x plus n minus 1 into k. And then we multiply this. Will multiply with this one. Then these two factors will be multiplied with this one, and so on. These three will be multiplied to the next, and at the end we will multiply with this one. Okay, so this is the first term, and this is the k. This is the value of this one. See in the MATLAB, this will be the value of this function. Okay. This will be the value of k poch. Each time this will return the value of k poch. Then the previous value will be multiplied to the next, and we will use this general term. This is the last. So according to the value of n, we have the term. Okay, when we have n equal to 1, then we have this value, very first value. When we have n equal to 2, then we have the next factor. When we have n equal to 3, then we have the third factor. And when we apply the for loop, in the form of product. Okay, so this will return the complete value of these factors. See in the MATLAB, because the code is very simple. So you can see this is the just general term. This is the general term or last term. This is the last term. Okay, and we are using R. R will vary from 1 to n because n is here argument. We need how many factors are required. Okay, so R will vary from 1 to n, and you can see here we have n minus 1. It means we need here R minus 1, and we will multiply with k. Okay, so product symbol will be there, and in the each syntax we require this product symbol. Okay, so the first value, if we have here only 1, it means we have only, if we have at this place 1, it means we have only first factor, which is x. When we will have at this place 2, it means we have two factors. One is x and next will be x plus k. And this will return the value of x into x plus k. X product with x plus k. Okay, but we are going up to for n. This will return n products. Okay, so each term will, this loop will work up to n terms, and then it will return the value. So now this is the complete program, and save it. Okay, so when you will save, now we are checking this one, is it correct or not, copying from this place. And also we know that when the value of k is 1, when the value of k is 1, it will be this very basic Pochhammer symbol. Okay, or the previous one. So now what I am doing here, I am assigning here the same values which we choose for at this place 4 and 5, and the value of k is 1. Okay, see the value of x is 4, and the value of n is 5, and the value of k is 1. And when I will enter, so now you can see the both the results are same. It means the program which we write here is absolutely correct. So while writing a program, we need to check whether the program is correct or not, and for that we check with the known function. So here Pochhammer symbol is known function, and this k Pochhammer, we create our own function. Okay, so now we have k Pochhammer symbol. Now we can use this function anywhere, whatever we required in any function. Okay, similarly we need just 1 minute. Similarly, we need this function. We need this k, and it is also very quite simple to write the program. And this function contains 2 arguments again, and the programming for this function is very quite simple. See the MATLAB, you can see here, yeah, this is the k gamma function, and I assigned here kg. Kg means k gamma function. Okay, and I define this function like k gamma, and you can see there are 2 arguments. One is z and other is k. These are the 2 arguments. Okay, so here the function is, see the function is which we are going to integrate. This is the function, and I denote it by n is equal to exponential, which is minus t raised to power k, and then divide it by t, divide by k, and multiply with the t raised to power z minus 1. Okay, so you can see here, this is the function and this is the other function, and we are using the product sign, but these 2 functions will be appeared in the form of array then we need the numerical registers. So when you have two functions and you are going to multiply these two functions, then only the product sign is not sufficient. You need along with this dot symbol, because these two functions are two arrays and we are going to multiply element by element. So along with this product sign, we need this dot sign, and this will return the correct value. There will be no error. You can see here is dot sign, here is also dot sign, dot with product. Okay, when the array is there and you want to apply one array with the another array, here are two functions, but these two functions are in the form of two arrays where we need numerical results. So only the product sign is not sufficient. This will return error. So you need here this dot sign also. Okay, now this is the function we create at its place, but this is the symbolic. So we need to define here a symbolic variable, which is SIMSD, as yesterday it was discussed. Okay, so now we are doing here integration function is there. This is the function, and this is the lower limit. Then we have the upper limit. Upper limit is infinity, and in the inbuilt function in the MATLAB is I and F stands for infinity. Okay, so now it and we you can use. See, I am copying from this place, and I want to verify the corresponding values for this function. See, we know if I have z is equal to 1 and the value of k is 1. When the value of k is 1, then it is simple, a basic gamma function. Okay, and when you enter, you can see the corresponding value, which is 1. Okay, gamma 1 is equal to 1. It means our program is correct. The program which we write here for the k gamma function is very correct, and we are checking. And now if you need to check for the other values. If you have k is equal to 2, okay, then this will change the value. See, okay, this is the numerical value, and you can simplify furthermore. Okay, so if it is 1, if you are changing, suppose that this value is 0. Suppose this value is 0, then it will return C. What it will return? It is returning 0. The k gamma is 0 when we have k equal to 0. Okay, so various experiments we can do after writing the program, and if you need the numerical as well as graphical interpretation, we can do. But due to lack of time, I will not expand all the things. See now, we are creating here k Mittag-Leffler function. Here is k Mittag-Leffler function, and where is k Mittag? See in the paper. Okay. Okay. Yes. So we have created a function for this. So what you need? See in the left hand side, what are arguments? Okay. One is gamma, then k, alpha, and beta. So you will write like in this way, and gamma, then we have k, then we have alpha, then we have beta. Okay, then equal to. This is the right side. The right hand side is a summation. So here we have to use for loop, and while you are going to apply for loop, you need first term, and first term means when you have n equal to 0, then what is the value of this part? This will be gamma 0 k upon gamma k beta. Okay, this part will become 0. So this is the very first. So first we need its initial value. Okay, see in the MATLAB. This is the syntax. So here is k methods. These are the arguments. See carefully. These are the arguments, and also z is variable. So this is the very first term. This is the very first term. Km is equal to I request you to just please mute yourself. I request to all the participants, please keep mute. See, so this is the syntax for the first term. In the numerator, you can see here is this function. This is k Pochhammer symbol, and in the k Pochhammer symbol, gamma is there, and value of n is 0. Okay, and we are using k Pochhammer symbol. We have created this function. Where we create, you can see. We are using this function. We are calling this function at this place. See this one. We are calling this function in a Mittag-Leffler function. See here. Okay. K Pochhammer. This is the gamma. These are the arguments which we are going to apply here. And the value of n is 0. And this is the k. Then we will divide by k gamma. See in the at this place. Denominator. This is the denominator, which is k gamma function. It is beta. It is beta. See here. So this is, we have written this function also, and we are calling at this place this one. You can see this function we have created, and we are using for the k Mittag-Leffler function. And very quite simple. Just you need to copy from this place and paste at this place. Just argument is beta. Argument is here beta in the place of z, and k is same. Don't worry. So this is the very first term. Now we are going to apply for loop, and we are using here for loop for n equal to 0 to 50. It means it will sum up first 50 terms, but this is not correct. We need at this place 1, because the first term at this place we have this one when n equal to 0. This is the very first term, and now we will add this term. The value corresponding to this one will be km, and this will put at this place automatically. MATLAB do itself automatically at this place, and then it will consider the next value for n equal to 1. When n equal to 1, that particular value will be from this place. And what is this one? What is this function? You can easily write from this place. See from this place. I will take only 5 minutes more, and it is about to complete. Note this point very carefully. Just 1 minute. See, so we need a script text for this one. So this function here in the numerator, this will be k gamma. Okay. Then argument. Then we have n. Then we have k. Then we divide by use at its place dot. This is k gamma function. Sorry, this was the k Pochhammer. Sorry, mistake is there. Okay, yeah. Just 1 minute. This is the k Pochhammer. Okay, you will use k Pochhammer. Then we have gamma, comma n, comma k. Then dot slash. Then write k gamma. Okay, this is the k gamma program we have created. And then what are the argument? Argument is k is there, alpha is there, beta is there, n is there. Then multiply it by z raised to power n upon n factorial. You can use n factorial, or either you can use gamma. You can use gamma n plus 1. Okay, same thing, no difference. So this is the rough script for this function only. And now note this very carefully in the add space. So this is the numerator, k Pochhammer, then we divide dot, this is the k gamma function. These are the arguments which are involving the function. This is alpha dot n plus beta comma k. Okay, and then we have z raised to power n dot k n, and then dot slash divided by factorial. At this place you can use also gamma n plus 1, but we are using a factorial function. Okay, and factorial n. So now, and after that, if you are going to start for loop, then we have to end the loop. Okay, so now this Mittag-Leffler function is complete. Save it, and now see very carefully, this k Mittag-Leffler function is evolving to more special functions. One is k Pochhammer and other is k gamma. Both we have create and we call in this function, and now we can easily plot these values. So now we need to assign, this is the k Mittag-Leffler function, and we have to assign the values of the argument. One is gamma, then we have k, alpha, beta, and z. So see at this place, the value of gamma we assign at this place 3, and we have value of k is 2.5, value of alpha is 4, and value of beta is 3, and value of z is, we at this place 0 to 0.5 with the increment 0. This value. This is the difference between two consecutive points or array. That is array from 0 to 0.5 with the difference of each point is 0.01. Okay, and we will pass all these argument with in this function, and then we are using here plot function. This is the plot function. This will plot the graph of this Mittag-Leffler function, and these are the x label, then we have y label, then gray grid is on, then box is on. These are the very basic commands for plotting the functions, 2D or 3D plotting, and all of these can be easily, we can find out in the MATLAB. Okay, so now when you will execute this file, you can see it will take some time, and it will return a very beautiful graph. You can see because there are multi-functions, and it will take some of first 50 terms, and then it will plot the graph and return on the dashboard. You can see this is the graph of Mittag-Leffler function. Okay, we assign from 0 to 0.5, and on the x-axis we have x label, and on the y-axis we have the k Mittag-Leffler function. Okay, and further, if you need to save or you want to insert more features, you can do easily. You need to go at this place, edit, then click at the figure properties. Then many things will be there. You can modify, you can do many things in this day. System is very heavy because many things are there. MATLAB is there, and these are the figure properties. Okay, it will open slowly. From these figure properties, you can modify or edit this figure. Okay.
Okay.
So these are the properties you can edit according to your choice. So this is a very simple process for the writing the script, writing the function, and all the same process we can implement for further extensions of the new functions This is the simple example for the Mittag-Leffler function. Okay, and according to the same, we can extend right function or a Bessel function, K Bessel function, or other the new functions like arithmetic functions. Okay, right functions. So all the functions we can write here, we can extend them, we can prepare their coding and script file, and we can plot them easily. In this way, I think this will be very helpful. And if you have any question from your side, please feel free to ask from me.
Any question from participant? Please ask. Any query or question? Nice talk delivered by Professor Mehar Chand to us, and this is a mixture of the MATLAB as well as the what is here the property means both method. Here you applied. It is analytical method as well as the numerical method. Means the what is here the application of MATLAB. Also you incorporated, and this is really very fruitful and nice talk. Okay, thank you. The certificate is I do not able to here share that. Okay, now please, okay, very good. Now, this is your one of the appreciation certificate. It's very useful and nice talk. Thank you, Professor Mehar. And very good.
Thank you, sir. Many participants are asking about the script file. Surely, yes. I will share all this content will be uploaded on the Google folder, and the link will be shared to all the participants who are attending this workshop on the Cisco WebEx as well as live streaming, and some will be not able to attend, but they will get all this content along with the cloud recording. We will provide them so that all this content will be very helpful for all the participants. Thank you, all of you.
Okay.
We all will resume the meeting at 1:45. There is about 20, after 25 minutes later. Okay. So still then you will be stay connected with us, and we will resume after 25 minutes. Thank you all of you.
Okay. Thanks to all.